Electric cars are a new groundbreaking invention that could revolutionize the world. Year after year, electric cars become more powerful, and in a few years, electric cars will replace IC vehicles. Because this invention is so important for the future of humanity, I feel like people should know more about how it works. After all, who's more qualified to talk about this than someone who's going to study in this field next year? Probably someone who is an expert in this subject and has a degree in engineering, but I'm still going to try my best. I'll start by explaining how electricity works, I'll then explain how the motor and the inverter work, and I'll finish with the battery pack and how the little batteries work. First, what is electricity? What we refer to as electricity is only a large number of electrons traveling generally through a circuit. An electron is the negative particle that travels around the nucleus of the atom. The flow of electrons is generally generated by a difference of potential. On one end of the circuit, the potential is negative, and on the other end of the circuit, the potential is positive. Because the electrons are negative and positive charges attract negative charges, the electrons will travel from the negative potential to the positive potential. This difference of potential is generally created by things like wall sockets or batteries. Now, how does the motor of an electric vehicle work? The motor of an electric car is an induction motor. An induction motor is composed of two major parts: a stator which doesn't move and a rotor that rotates. The stator is a three-coil winding in which goes a three-phase alternative current. This winding goes through the slots of the stator. When a three-phase alternative current goes through this winding, something interesting happens. It produces a rotating magnetic field. Normally, when an electric current goes through a wire, it creates a stationary circular magnetic field. But because the current is a three-phase alternative current, which means that the direction and intensity of the current going through the three wires are always different from one another and always changing, it creates a rotating magnetic field. If you put a closed circular conductor like our rudder in this magnetic field, because of Faraday's law of induction that states that when a magnetic field is interacting with an electric circuit and this magnetic field is changing, the interaction will produce an electromagnetic force in the circuit that will induce a current. This inducted current in the conductor will in turn create an upward electric force on one end of the conductor and a downward electric force on the other end, according to the Lorentz force law. The Lorentz force law basically states that a current will create an electromagnetic force proportional to the intensity of the current. It also states that the direction of the current dictates the direction of the electromagnetic force. When the current goes to the right, the force is going downwards, and when the current is to the left, the force is going upwards. Because the force on both ends of the conductor are opposed, the conductor will start to rotate. In an induction motor, instead of having a simple circular conductor in the center of the magnetic field that rotates, we use metal bars that are arranged like an hamster wheel that rotates. It's because of this rotation that the wheels of the electric car will turn. To change the speed of the vehicle, you only have to change the frequency of the alternative current going through the coil. But where does the induction motor get its alternative current from? The alternative current is generated by the battery pack, which gives direct current, which is converted to alternative current by an inverter. Direct current is current that is going only one way, where the electrons will go from the power source to the thing that needs electricity and back to the power source. An alternative current is when the electrons will go back and forth in the circuit. To transform direct current to alternative current, the inverter will change the direction of the direct current at a certain frequency. To explain the principle behind the inverter, we will have to imagine a simplified version of an inverter. This simple inverter is a circuit with a direct current source, four switches, and an object that needs AC current in the middle of this circuit. Here we have situation 1 where the switches S2 and S3 are on and the current goes to the right, and we have situation 2 where the switches S1 and S4 are on and the current goes to the left. By alternating between situation 1 and 2, an alternative current is created. The frequency of the switching between situation 1 and situation 2 is the frequency that our alternative current will have. However, by doing it this way, we'll have a function that looks like little squares when we want a function that looks like a sinusoidal function. To achieve that goal, we will give power to the source at different lengths of time to simulate a sinusoidal function. Because of the ability of the inverter to control the frequency of the alternative current, it is considered to be the brain of the induction motor. The direct current is made by a battery pack containing little lithium-ion batteries that will generate the electricity needed to make the vehicle move. A lithium-ion battery is like any other kind of battery. It has an anode, a cathode, an electrolyte solution, a separator, and two conductive metals on each side connected by a wire. The negatively charged anode is made of carbon, the positively charged cathode is made of some sort of lithium metal, the conductive metal near the anode is made of copper, and the one near the cathode is made of aluminum. In a fully charged battery, the positively charged lithium ions bond with the carbon of the anode. The electrons are in a very unstable situation and want to get to the cathode to become more stable. But the separator in the electrolytes prevent the electrons from going to the cathode through the electrolyte. By connecting a circuit from the copper touching the anode to the aluminum touching the cathode, a pathway for the electrons from the anode to the cathode is created, and electricity for the motor is generated. Meanwhile, in the electrolyte, the lithium ions that are no longer bonded with the carbon because they have lost an electron travel from the anode to the cathode through the electrolyte. Once all the lithium is in the cathode, the battery is fully discharged, and it needs to be recharged if we want to use it again. To recharge the batteries, you only have to reverse the process and make the lithium ions and the electrons go from the cathode to the anode by creating a difference of voltage that will make the electrons and the ions want to go back to the anode. In conclusion, the battery pack of the electric car powers the vehicle by giving it direct current with lithium-ion batteries. The current is then transformed and controlled by an inverter that will regulate the speed of rotation of an induction motor that will make the wheels of the car rotate. I hope you have learned a lot in this presentation and are impressed by the ingenuity of the engineers that have designed this wonderful invention.